Okay, we will make this sequence of cylinder. Extend A, extend B, retract A, and retract B. So in this case, I will have two cylinders. Yes, these are sensors, electrical sensors. Might be proximity sensors or limit switches. So these two cylinders are doing work at this sequence. So we will apply the sequential principle here, maybe with or without timers. We have now the pneumatic circuit, and these are the solenoid valves. So we need push buttons. Emergency stop, you can add a circuit breaker there. We have some rules and tips how to do this one. We have to determine the cylinder sequence. Okay, this is the cylinder sequence. If you have two cylinders, that is also the number of solenoid. Okay, number of solenoids. So you can have this one. So number of solenoids equals the number of cylinders, or that way. Number of cylinders equals the number of solenoids. Next, if we have two cylinders and the sequence states A plus B plus, number of sequence, there are four sequences there. A plus B plus sequence is equal to the number of relays plus 1. Okay, number of sequence, so we call that one the number of sequence, or sequences, equal to the number of relays plus 1. The last one relay will be the reset. We will see that later. We can add later if we are making the electrical circuit. Let's say if we have the number of sequence is equal also to number of sensors. That way. So we will add some later. These are the basic steps we need to make the electrical circuit. And of course the basic knowledge of electrical controls using relays, contactors, push buttons, timers. They have similar operations here because we have electrical controls driving these motors in electrical. These are relay coils, relay contacts, equivalent. The sensors here are this one, proximity or limit switches or reed switch. These are the sensors. Capacitive, magnetic, inductive, optical, the light, magnetic reed switch, the reed switch, proximity magnetic. And you can have the roller switch. So we can convert this one into a roller switch, limit switch. Next, how many relays? We have 5 relays because we have 4 sequence there. How many sensors? 4 sensors. This is not considered a sensor, that is a switch to start the operation. So start stop, basic start stop control. So we need 5 relays. One, two, three, four, 5. It depends on the circuit we are trying to make. We need timers. We need some space here. Okay. You have to determine the cylinder sequence, number of solenoids, number of sensors, number of relays. We will add some later. That is emergency stop. You can add a circuit breaker you want. In reality, you have fuse or circuit breaker. Number of solenoids. There are 2 solenoids. These are solenoid bulbs. Y1 and Y2. We can separate the solenoid if they have different voltages. Let's see Y1. So solenoid Y1, solenoid Y2. Any level you want. So we need separate supply. Two power supply because we need the separate voltage of the solenoid. We put it that way, that they have different voltage. Solenoids usually have different voltage. We will connect them later. We don't have the controlling contacts, the auxiliary contacts. R1 or relay 1. Connect, branch out. Next, we have to latch all the relays. So you are going to add the latch all the relay. Holding contact. And the rule there is latch the relay except the last one. So we will add latch all the relays except the last one. Latch all relays except the last one. And the last relay is the preset relay. Okay. But we have sensor in the last relay also. We will connect this. Or how many we have? Sensors and relays. So one of this is the sensor, one is the latching contact. You can turn on the grids. Okay, when we say latch, normally open. When you say interlock, normally close. Okay, all latching connect all together up. So the basic circuit there is the start-stop circuit, latching, emergency stop, or the normal stop. In pneumatics, electro pneumatics, you also that one, emergency stop or the normal stop. Latch, okay, latch. So latching is that way, and this is the normally open or relay one. No latching at the last contact. That will be a sensor. One. This is R2. You can label say na you want as long as you have documentation. This is the R5. You can label this one as the reset. The last relay is the reset, to reset all the operation. That is the role also of sequential, automatic sequential, A plus, B plus, A minus, B minus. Okay, we will add the role of sequential using contacts of normally open relay. The sequential role using the normally open contact is this one. If you remember that sequential operation of relays, we have that circuit. Semi-automatic sequential, but here we can automate because of the sensor here. So we need the normally open contact. So this is how to automate using the normally open contact. The one we have the manual sequential. Okay, you can either use the principle of semi-automatic sequential. So if this one is turning on, that is on, that sensor will turn on, that on, that on, this one, this one, this one, this one. Okay. If cylinder A is turning on, it will trigger the sensor A1. So we will have this one as sensor A1. Okay, and that sensor A1 is this one. If you are going to place this one, where is the roll? This one, distance roll. You can add the pneumatic sensor. Then you can add the sensor A, sensor A1, and you can specify 50 or 100 millimeter the distance of the cylinder. You can use this one, but that is a simple. We need a simple sensor first. Next, then it will trigger A1 and turn on this one, and this one will extend. That will hit B1. So B1. We can make the state diagram or function diagram later. Even if you don't have that one and you know the sequence, you will try to figure out. Next, what will happen next? This one extended, this one extended. This one will trigger the retraction of A. So that means B1 triggers R3. So this one, R3 will turn off the solenoid one. And it will trigger the A0. So A0 triggers retraction of B1. And in turn B1 will hit the BO. Okay. They have this symbol because they are represented by initially triggered. Initially triggered means this one, this sensor is initially open, but when placed near to the cylinder, it is triggered, becomes closed, that symbol. Okay, so the differentiator that is normally open, but initially triggered, become closed because that is near to the cylinder head. But it will not cause on air because we have normally open. So remember, this is R1. R R3, R4. So they are all initially open. And we can solve now the power circuit. You can add here. What causes this to turn on? A plus, B plus, B minus, B minus. Here. Okay. B plus, A plus, A minus, A minus. This one is used for extension and retraction of A. The other one is used for the extension and retraction of B. So you have here B. In this way, we can see also the contacts we are going to use up to trigger and remove the supply of the solenoid. Here, remember, A plus is triggered by this one, push button. At the same time, since that is indirect, we are going to control that with the relay contact. So we need one more relay here. Okay, let's try. You will finish the control later. You will cut off this one first. Look off. You will trigger first the first relay. They're outside the working area. Okay, that one. How to turn this off? This one should turn that off, but we are not triggering that one yet. We are not supplying this one yet. So turn off. This one will trigger via R2. This one turns on. So we need R2 here. Remember, normally open contact is to turn on, to make a circuit. That is to make a circuit. Again, make switch, to make contact. R2. Again. Okay. Since we did not place the contact and no triggering of R3, R3 will turn off this one. That is hit by B1. They are now in 2 extended position. Turn off. So again, the one that turns off is normally closed. And R3. So place this one R2 to continue the operation, and we need R3 to open, and that will be a normally closed contact. R3. Okay. Trigger. Now, how to open this one? How to open this one? This is returning now. This should open the solenoid of cylinder 2. This is Y2. So we are going to open this one with R4. R4. Okay. Okay. What happened here? Oops. That is R4. Okay. See, there is all the supplies there, but there was no more air because it already returns. How to reset this one? This is the purpose of this relay. So what we did in the interlock is to turn off the first relay. The purpose of interlock is to turn off, right? So how to turn this off? Then there is no latching here. This will not turn on. If normally close is place here to break R1, that will turn on. Break R2, that will turn on. Break R3, that will turn off. And turn it off. All the circuits in there is no latching there. Latch all relays except the last one. No latching there. So we will have this one as reset. If you name that one there as reset, the contact is there should be reset also. let's say R5, no problem. Okay, okay, to make it simple, RS, press that. They should have, must have the same label. No, we have the complete cycle. A plus, B plus, A minus, B minus. If you hold this one, there is a continuous operation. But are we going to hold this one forever? You don't need to hold that one. What switch to be used? We need the normally closed, normally open latch switch or D10 switch and do a parallel connection. Let's say it's for cycle. Switch for cycle. Cycle operation means you can continue the operation. You have the option to cycle the operation. Okay, question. Again, this one is initially triggered, that's why that is closed, but no current there. When you place the sensor near the cylinder head, the cylinder piston, that is sensed as triggered. That's why they have that one. They will stop the operation. One, this will give air supply there. Air. Depending on the setting of the flow controllers. You have to click all. Then hit B1. B1 will turn on. Pre-release on. Sensor A0 will trigger the retraction. B1, the retraction of A. A0 triggers the retraction of B1. When the B extend, this one is open, so no supply there, similar with this one. Air is flowing there, retracting the cylinder, so the pressure is there. Now, reset, there is a chain reaction. Okay, you can add the safety for pneumatics, safety for electrical. If we want to add the state diagram, state diagram, you can make also this one for the function diagram. that is outside the area. Uh, they cannot see. Yes, here. A plus, B plus, A minus, B minus. So one complete cycle. Let cylinder A, cylinder B. Okay. If you want the function chart, you can make also the function chart. Even this one, if you are familiar with that sequence, function chart, you can do it manually or you can do it here. But better to do it manually first in a paper. Do it this way. This one traverse. A1 equals B. And B equals B. A0. A0 to B. And B0. So therefore, cycle. Insert function level. This is basically the graphical presentation of this one. You click, double click, add, add. Okay. And remove this one. Do it again. Red. Red. Yes. Okay, they are similar. You can adjust this one. They look similar. Okay. That's it. Any of this is given. This one. This one is given. This one is given. How to do this one? Edit and is given. You will do this one. You can do this one separately. And that's it. Thank you. Please subscribe and have a happy day. Don't forget this. You can add some.